Problem number 1. Oil with a specific gravity of 0.80 forms a layer 0.85 meters deep in an open tank that is otherwise filled with water. The total depth of water and oil is 3 meters. What is the gauge pressure at the bottom of the tank in kilopascals? So before we start to solve this kind of problem, let's analyze first what would be the figure for this problem. So this is the solution. Let's say we have an open tank. Before we continue, dapat ma-set up muna natin kung ano yung magiging location ni oil at ni water. Kung sa taas ba or sa baba. So base sa knowledge natin, nasa baba si water with corresponding height of H sub W. At nasa taas naman si oil with corresponding height of 0.85 meters. And the total depth of the two is equal to 3 meters. So why does oil float on top of water? Oil floats on top of water because oil is less dense than water and it is what is known as hydrophobic. So meaning to say, mas magaan si oil kumpara sa water. At ma-compare din natin yon in terms of their specific gravities. Wherein yung oil has a specific gravity of 0.80 at yung water has a specific gravity of 1. Pero bakit 1 yung value ng specific gravity ng water na hindi naman nabanggit sa problem? Ngayon, babalikan natin yung concept ng specific gravity, wherein specific gravity is equal to the ratio of densities or the unit weights of any fluid with respect to water. So bakit natin lagi kino-compare sa water? Kasi sa fluid mechanics or hydraulic engineering, the most common reference fluid is water. So kung isa-substitute natin yung density ng water sa density ng fluid, so ang mangyayari, density of water over density of water, malamang ang lalabas ay 1. Kaya specific gravity ng water ay 1. So ngayon, merong constant value ang density ng water equal to 1,000 kg per cubic meter. Ganon din naman yung unit weight of water, 9,810 Newton per cubic meter. So if you want to convert it to kilonewton, then you should divide it to 1,000. Therefore, 9.81 kilonewton per cubic meter. So as you can see, pwede natin ipapakita or pwede rin nating ipakita yung relationship ni density kay unit weight by using unit analysis. So sa density, ang unit ng density ay kilogram per cubic meter. Wherein yung kilogram corresponds to the mass. At yung cubic meter corresponds to the volume. That's why yung formula ng density ay mass over volume. How about the unit weight? So sa unit weight naman, Newton over cubic meter. So yung Newton corresponds to the force or the weight. At yung cubic meter naman corresponds to the volume. Kaya yung formula ng unit weight is weight over volume. Dapat nating mapansin na may multiply tayo sa kilogram para maging newton. Kasi pares naman na sila ng denominator. Yun yung cubic meter, so pares na volume. So ano yung i-multiply natin sa kilogram para maging newton? So base sa knowledge natin, i-multiply natin ng acceleration due to gravity, wherein yung unit nun ay meter per second square. So kilogram times meter per second square is equal to Newton. So, as is yung over cubic meter. So, I hope matandaan niyo yun na kasi itong formula na 'to ay talagang gamit na gamit sa fluid mechanics or sa hydraulics. Therefore, unit weight is equal to density times gravity. Okay? So, balik tayo sa problem, no? Ano ba yung hinahanap? So, what is the gauge pressure at the bottom of the tank in kilopascals? So, ito yon. Yan. Yan yung location na hanapan natin ng pressure at the bottom. So, ito yung formula for pressure. Summation of pressure is equal to summation of gamma times height. So, yung gamma dyan, gamma ng fluid. So, paano natin makukuha yung gamma ng fluid? Okay, we can cross-multiply the gamma of water to the specific gravity. Therefore, gamma of fluid is equal to specific gravity times gamma of water. Okay? At yung hinahanap na unit for the pressure is kilopascal. Ayan. Ano ba yung pascals lang? 'Di ba equivalent yun to Newton per square meter? Since kilopascals ang hinahanap, edi kilonewton din. Ayan. So, mapapansin nyo rin na yung pressure is equivalent to force over area. Okay? Tingnan ulit natin yung figure. Makukuha na rin pala natin yung value ng HW. Wherein, HW is equal to 3 minus 0.85 meters equal to 2.15 meters. So let's now solve the gauge pressure at the bottom. So ito na yan. Pressure at the bottom is equal to 0.80. Okay, magsisimula tayo sa taas ng oil, pababa. Okay, 0.80. Ito yung specific gravity ng oil, SO. 9.81 yung gamma of water. At yung corresponding height na 0.85. Yun yung para sa oil. Then, idagdag natin yung sa water. So, specific gravity ng water ay 1 SW. At yung 9.81 gamma of water. At yung height naman ng water na 2.15 na nakuha natin kanina. So, height ng water. So, if you calculate the sum of the pressures, you will get 27.7623 kilopascals. Kasi kung titingnan nyo dito, so ito, may unit na kilonewton per cubic meter times the height na meter. So, cancel. Ang matitira na sa baba ay dalawa. So, kilopascal. Okay? So, again, the pressure at the bottom is 27.7623 kilopascals. And that's the final answer. That's it.